Hey everyone, welcome back to CodeMechanic. Today, we're diving deep into a critical safety component of your car. The ABS wheel speed sensors. Ever slammed on your brakes and felt that pulsing in the pedal? That's your ABS system at work. And these little sensors are the unsung heroes making it happen. They're not just for braking, though. They're also essential for your traction control and electronic stability control systems. Stick around, and I'll show you exactly how they keep you safe on the road. So, how do these sensors actually know how fast each wheel is spinning? It's all about magnetism and precision. Most modern cars use what's called a magnetic encoder, or tone ring, which is integrated right into the wheel bearing or hub assembly. This ring has a series of north and south magnetic poles embedded in it. As the wheel turns, this magnetic ring spins past the stationary wheel speed sensor. The sensor, which is essentially a Hall effect sensor or a magnetoresistive sensor, detects the changing magnetic fields. Think of it like this. As each magnetic pole zips past the sensor, it creates an electrical pulse. The faster the wheel spins, the faster these pulses are generated. The car's computer, the ABS module, reads this stream of pulses as a square wave signal. It's constantly monitoring the frequency of this signal from all four wheels. If it suddenly detects that one wheel's signal is dropped, 2-0, while the others are still spinning fast, meaning that wheel has locked up during hard braking, it springs into action. This is where the magic of ABS happens. The ABS module will rapidly pulse the brake pressure to that specific wheel, applying and releasing the brake multiple times per second. This allows the wheel to regain traction and continue rotating, which means you can still steer the car and maintain control, preventing a dangerous skid. The same principle applies to traction control, just in reverse. If a wheel starts spinning too fast during acceleration, the system can apply a little brake pressure to it or reduce engine power to help it regain grip. Now, let's talk about what happens when things go wrong. You'll usually get a trio of warning lights on your dash. The ABS light, the traction control light, and sometimes the brake warning light. Common trouble codes associated with wheel speed sensor issues range from C0035 to C00, with each code pointing to a specific sensor, circuit like C00354, the left front, C00404, the right front, and so on. Diagnosing a faulty sensor is pretty straightforward with a good scan tool. The first thing you'll want to do is look at the live data stream. Drive the vehicle slowly and watch the wheel speed readings for all four sensors. They should all read very close to the same speed. If you see one that's erratic, lagging behind, or stuck at 0, you've likely found your problem child. Before you rush out and buy a new sensor, always perform a visual inspection. The sensor and its wiring are exposed to the elements. Look for any physical damage, corrosion on the connector, or frayed wires. Sometimes, the problem isn't the sensor itself, but the magnetic tone ring. Because it's often part of the wheel bearing, it can get contaminated with metallic debris from brake dust or other road grime. This debris can interfere with the magnetic field and cause an incorrect signal. In many cases, you can simply clean the sensor tip and the tone ring area. Use a brake cleaner and a soft brush to gently remove any buildup. After cleaning, clear the codes and take it for another test drive, monitoring the live data. If the reading is now smooth and consistent, you've fixed it. If the problem persists, or if the sensor's internal circuit has failed, then it's time for a replacement. Replacing a wheel speed sensor is usually a simple job, often just 1 or 2 bolts and a connector. And that's the rundown on ABS wheel speed sensors. They are a perfect example of how simple physics can be used to create an incredibly effective safety system. Understanding how they work not only helps you diagnose problems, but also gives you a greater appreciation for the technology keeping you safe every time you drive. Thanks for watching, everyone. If you found this video helpful, give it a thumbs up and consider subscribing for more deep dives into automotive tech. Drop any questions you have in the comments below. Drive safe, and I'll see you in the next one.